Welcome to the photocop example for confidence intervals for proportion. Recently, 829 adult Tennesseans were surveyed, and 51% of them opposed the use of the photocop for issuing traffic tickets. Use the survey to answer the following. The sample proportion, remember, is the sample, the best point estimate is a sample proportion, and in this case, it's the 0.51, 51%. That means Q hat, probability of it not happening, is 1 minus 0.51 or 0.49. Next, to get our margin of error, we're going to have to use the formula z critical value times the square root of p hat times q hat over n. Our z critical value, according to our chart from the other page, is going to be 2.3263 for the 98% confidence level. Let's substitute all those values in. 2.3263 times the square root of 0.51 times 0.49 p hat and q hat divided by n, which is 829. Try that on our calculator. 2.3263 times the square root of 0.51 times 0.49 divided by 829. There we go. Write all the decimal spot down. 0.04038978889. Okay, which is approximately 4.04%. So we have in mind what it is. Next, at the 98% confidence level, we're going to construct the population proportion of P. So we take our P hat, which is 0.51, and our margin of error we just calculated, and we put them together by adding and subtracting. So I'm going to go 0.51 minus 0.04038978889. That will give us our lower limit. Let's go ahead and calculate that out. 0.51, minus 0.04038978889. So our lower limit will be 0.469610211. Okay, that's our lower limit. So less than P, which is less than, and then that signifies it's between. We take 0.51 plus our margin of error, 0.04038978889. Okay. So our upper limit, instead of subtracting, we just add that. I can go 0.51 plus 0.038978889, and I get 0.5503897889. Okay? And again, if you wanted to convert them to smaller decimals or percents, that would be fine. So we are, and we have to state how confident we are. Well, in this problem, it says we're at a 98% confidence level. So we are 98% confident that the population, and we're talking about proportions here, proportion. You could also say percentage, population percentage of all adult Tennesseans who oppose the use of the photocop is between, and this is where I'm going to round, 0.4696, which is 46.96%, and 0.5504, or 55.04%. So remember, it predicts a range of values the population proportion would be in. Let's go ahead now and answer the other question. Let me move this a second here. There we go. You can see it now. Okay, based on that result, we can safely conclude that the majority of adult Tennesseans oppose the use of the photocop? Well, we know that it's somewhere between 46 and 55%. Remember, majority means over half, or over 50% in this case. So we can't safely say, because both percentages are not above 50%. Or you can say that 46.96 is below 50%. Let's go double check our work on Statcrunch. Okay, so on Statcrunch, remember what we have to do? We have to go to Stat, and then, let me click on there, opens it up, proportion stats, one sample with summary. Our number of successes. Well, our number of successes, it said 51%. So with 51%, it doesn't tell us an exact number. So this is where we have to do some calculations here. So X is going to be 0.51 times the 829. So we have to figure that out first. So 0.51, let me move it down a little bit here. 0.51 times 829. That will leave us 422.79 Tennesseans that oppose the use of the photocop. So we're going to need this for Statcrunch. We might need it for any other sort of technology too. So let's see, 422.79. Our number of observations was 800.79. Our number of observations was 829. That's our sample size. We have to change our confidence level. Hit the confidence interval for a P button. Our confidence level is 98%. Then we're going to go ahead and hit compute. We can see our sample percentage is 0.51. Our lower limit, 0.4696, is the same percentage that we got in our problem that we just did. Our upper limit is 0.5504, same thing. Notice again, our margin of error, Statcrunch unfortunately doesn't calculate, so we'll have to use our calculator and the formula or the table for our critical values in order to calculate.